Question 1. Based on the information, Maria notices that her Oracle database shows a significant increase in dbeat time, but the CPU usage remains steady. She suspects a wait event is causing the bottleneck. What should Maria prioritize to identify the root cause? A. Examine the top timed events section in the hour report. B. Check the size of the buffer cache to see if it's too small. C. Analyze SUL execution plans for poorly performing queries. D. Increase EGA memory allocation to reduce sorts on disk. Answer. Correct answer. A. Explanation. When dbeat time rises but CPU usage remains steady, it usually indicates that sessions are waiting on some resource rather than consuming CPU cycles. The top timed events section in the I report lists the events that sessions spend the most time waiting on, helping identify wait-related bottlenecks. Checking buffer cache size or PGA memory might help with resource issues, but they don't directly pinpoint wait events causing high EP time. Analyzing SUL plans is important but secondary in this scenario, as the wait event focus offers a clearer starting point. Question 2. In a context of SUL tuning, David is reviewing a complex query that performs poorly despite having correct syntax and indexes. Which concept best explains why the optimizer might choose a suboptimal execution plan? A. Stale optimizer statistics causing inaccurate cost estimation. B. Excessive PGA memory leading to suboptimal sorts. C. Large buffer cache causing contention issues. D. Incorrect use of automatic shared memory management ASM. Answer. Correct answer. D. Explanation. Incorrect ASM configuration can cause improper allocation of memory components like the shared pool and buffer cache, indirectly influencing the optimizer's ability to execute efficiently by affecting parsing and caching of execution plans. Stale statistics directly cause bad plan selection but are not related to memory management. PGA memory size affects sorts but does not explain optimizer choice. Cache size affects EO but not execution plan selection. Question 3. Istha Patel is tasked with diagnosing why his database's active sessions spike during peak hours. Given the circumstances, which tool should he use for detailed session-level analysis in near real time? A. Active session history ASH reports. B. Static hour snapshots comparison. C. SQL plan baseline management. D. Enterprise manager alert logs. Answer. Correct answer. C. Explanation SQL plan baseline management ensures execution plans remain stable and predictable, but it does not provide real-time session-level diagnostics. Active session history ASH captures detailed session information at a fine granularity and is best suited for analyzing spikes in active sessions near real time. Our snapshots provide historical data, but not near real time. Enterprise Manager alerts provide high-level notifications, but lack detailed session info. Question 4. Considering the evidence, Jane wants to ensure her SUL tuning efforts yield consistent results despite changes in data volume. What is the best practice she should follow? A. Use SUL plan management with SUL plan baselines. B. Gather optimizer statistics once and never update. C. Disable automatic SUL tuning to prevent plan changes. D. Rely solely on hints embedded in SQL statements. Answer. Correct answer. A. Explanation. SQL plan management with plan baselines maintains stable execution plans even as data volume or schema changes occur, preventing regression. Gathering stats once and never updating leads to stale data and poor plans. Disabling automatic tuning removes optimizer adaptability and can hurt performance. Over-reliance on hints can cause fragility and maintenance issues as conditions evolve. Question 5. From a practical standpoint, in a system experiencing excessive latch contention in the shared pool, what is the most appropriate first step for Tom to take? A. Increase the size of the shared pool to reduce contention. B. Add more CPUs to reduce latch wait times. C. Disable automatic workload repository I to reduce overhead. D. Modify SQL statements to use more optimizer hints. Answer. Correct answer. D. Explanation. While increasing the shared pool size can sometimes alleviate latch contention, the root cause often lies in repetitive hard parsing due to non-optimal SUL. optimizing SUL to reduce hard parsing, for example by using bind variables or hints, addresses contention more effectively. Adding CPUS does not directly solve latch contention. Disabling AR removes important diagnostics and is not recommended. Question 6. Under the assumption that a DA wants to proactively tune a database, which component of the diagnostic and advisory framework DAF provides automated analysis and actionable recommendations? A. Automatic database diagnostic monitor ADAM. B. Active session history ASH. C. SQL performance analyzer SPA. D. SQL access advisor. Answer. Correct answer. B. Explanation. The ADAM provides automated root cause analysis and tuning recommendations by analyzing data, making it the primary proactive tuning component. ASH collects session activity samples, but does not analyze or recommend. SUL performance analyzer tests SQL impact for system changes, but is reactive. SUL access advisor recommends indexing strategies, but does not analyze system health. Question 7. Reports show a sudden rise in EO wait times on a specific table space during the last week. Samantha suspects segment space management issues. What advanced method should she apply to reduce row migration and chaining? A. Use segment shrinking and table compression. B. Increase the buffer cache size. C. Add more CPUS to handle the workload. D. Disable automatic memory management. Answer. Correct answer. C. Explanation. While adding CPUS may improve overall throughput, it does not address row migration or chaining, which are related to how data rows are stored. Segment shrinking and table compression directly reduce fragmentation, row migration, and chain rows by reorganizing data efficiently. Increasing buffer cache helps with EO but does not solve row chaining. Disabling AM affects memory management but not segment spacing. Question 8. Given the circumstances, Roger's monitoring latch and mutex contention in his system. What is the key diagnostic step he should take to differentiate between the two types of contention? A. Use views to identify wait events specific to latches and mutexes. B. Run SQL trace to find the slowest SUL statements. C. Increase EGA allocation to minimize memory contention. D. Check our snapshot load profile for CPU edge trends. Answer. Correct answer. A. Explanation. views provide detailed wait event information allowing differentiation between latch and mutex contention by identifying specific wait events like latch-free or mutex sleep. SUL trace focuses on SUL execution, not contention types. EGA size affects memory, but not directly latch mutex waits. Load profile shows EPU edge trends, but not detailed contention diagnostics. Question 9. During the process of tuning, Lina notices excessive temporary table space usage due to sorts spilling to disk. What is the best course of action to optimize this? A. Increase PGA aggregate target to accommodate in-memory sorts. B. Reduce shared pool size to allocate more memory for sorts. C. Enable SUL plan baselines to stabilize execution plans. D. Disable our snapshots to reduce overhead. Answer. Correct answer. A. Explanation. Increasing PGA aggregate target allows more memory for sorts and hash joins to occur in memory, reducing temporary table space usage. Reducing shared pool size does not impact sort memory and could hurt parsing. SUL plan baselines stabilize plans but don't directly reduce temp space. Disabling I removes diagnostics and is not advisable. Question 10. Several experts suggest that when analyzing performance differences between two time periods, which our report feature provides the most direct comparative insights. A. Our compare periods report. B. TSUL execution plans section. C. Buffer cache hit ratio summary. D. Automatic workload repository snapshot baseline. Answer. Correct answer. D. Explanation. The Our Compare Periods report is specifically designed to compare performance data between two snapshots, giving direct comparative insights about workload, wait events, and resource usage. The TSUL execution plans and buffer cache hit ratio offer snapshots, but not comparative analysis. Baseline snapshots are reference points but do not inherently provide direct period comparisons. Question 11. In the context of database tuning, Michael observes that his system has a sudden increase in wait times related to latch-free events. What is the best initial approach for Michael to diagnose and resolve this issue? A. Review SUL statements causing frequent hard parsing and implement bind variables. B. Increase the size of the buffer cache to reduce disk I/O. C. Add more CPUs to reduce contention. D. Disable automatic shared memory management to manually tune memory components. Answer. Correct answer. A. Explanation. Latch-free waits often occur due to excessive hard parsing, which consumes latches protecting shared pooled structures. By identifying and optimizing SUL statements that cause frequent hard passes, such as by using bind variables, latch contention can be greatly reduced. Increasing buffer cache or CPUs won't directly address latch contention. Disabling ASM can complicate tuning without guaranteeing relief from wait. Question 12. Given the circumstances, Priya is analyzing an hour report and notices that the DB time metric is disproportionately higher than EPU time. Which of the following best explains this scenario? A. Sessions are spending significant amount of time waiting on non-EPU resources, such as I/O or locks. B. The CPU is overloaded, causing increased response times. C. SUL execution plans are highly inefficient and consuming CPU cycles. D. There is excessive parsing causing CPU saturation. Answer. Correct answer. B. Explanation. A disproportionately high EB time compared to EPU time indicates sessions are waiting more on resources like I/O locks or latches rather than EPU-bound tasks. EPU overload would cause CPU time to match or exceed EB time. Poor SUL plans or parsing cause CPU consumption but would reflect in CPU time, not just EB time. Question 13. Mr. Lee wants to maintain consistent SUL performance despite frequent statistics updates on his production system. What Oracle feature should he implement to safeguard execution plan stability? A. USUL plan baselines managed through SUL plan management. B. Disable statistics gathering entirely to keep plans unchanged. C. Force the optimizer to use rule-based optimization instead of cost-based. D. Apply optimizer hint aggressively in all CRITIA SUL statements. Answer. Correct answer. C. Explanation. Disabling statistics or reverting to rule-based optimization can cause plans to remain consistent but leads to suboptimal performance with modern optimizers. Aggressive hints reduce flexibility and maintainability. SUL plan baselines are the recommended way to ensure plan stability and adapt to statistics changes, not disabling stats or rule-based mode. Question 14. As illustrated by recent performance data, Jessica finds that high PGA memory usage is causing swapping on her server, degrading overall performance. Which approach should she take to 2 PGA and reduce swapping? A. Lower the PGA aggregate target and monitor for improvement. B. Increase the shared pool size to compensate for PGA pressure. C. Disable automatic memory management and configure manual memory allocation. D. Increase the buffer cache size to offload memory usage. Answer. Correct answer. B. Explanation. High PGA memory leading to swapping is usually addressed by reducing PGA allocation, not increasing shared pool size, which is unrelated. Disabling M might help but is complex and not a first step. Increasing buffer cache doesn't impact PGA memory or swapping directly. The best immediate action is to lower PGA aggregate target and tune workload. Question 15. Under the assumption that the SUL tuning advisor suggests creating new indexes for a poorly performing query, what should Daniel consider before implementing those recommendations? A. Evaluate the impact of additional indexes on DML performance and storage overhead. B. Immediately create all recommended indexes without delay. C. Disable SUL plan management to allow optimizer freedom. D. Use optimizer hints to force the new indexes in execution plans. Answer. Correct answer. D. Explanation. While evaluating impact on DML and storage is crucial, forcing optimizer hints blindly is not best practice because it can cause brittle plans. Immediate creation of all indexes can cause excessive overhead. Disabling SUL plan management removes plan stability. Hence, Daniel should carefully evaluate indexes' impact before implementation, but forcing them via hints is less advisable than baselines. Question 16. During a performance baseline comparison, Sarah notes that the load profile in the recent period shows a significant increase in physical reads. What is the most logical explanation for this observation? A. Buffer cache hit ratio has declined, causing more disk I/O. B. EPU capacity has increased to handle higher loads. C. SQL statements are using more bind variables. D. Shared pool size has been increased. Answer. Correct answer. B. Explanation. Increased physical reads usually correlate with a decline in buffer cache hit ratio, not CPU capacity. CPU increases don't cause physical reads directly. Use of bind variables improves caching and reduces physical reads. Increasing shared pool size does not affect physical reads. Therefore, the most logical explanation is the decline in buffer cache efficiency net CPU changes. Question 17. When faced with frequent segment-level contention and row chaining in a critical table, Roger's considering tuning options. Which method will most effectively address this problem? A. Use segment shrinking and table compression to reduce fragmentation. B. Increase the size of the shared pool. C. Disable automatic workload repository to lower overhead. D. Adjust PGA aggregate target to reduce sewing spills. Answer. Correct answer. A. Explanation. Segment shrinking and table compression compact the table's data, reducing fragmentation and preventing row chaining migration. Increasing shared pool size is unrelated to segment-level contention. Disabling OR removes performance insight but doesn't solve fragmentation. PGA adjustments affect solving but not data fragmentation. Question 18. From the perspective of diagnosing high latch contention on cursor pin events, what is the most effective tuning strategy to apply? A. Implement cursor sharing via bind variables to reduce hard parsing. B. Increase the PGA memory to reduce parsing weights. C. Disable SUL plan baselines for more optimizer flexibility. D. Increase buffer cache size to reduce disk I/O. Answer. Correct answer. C. Explanation. Cursor pin latch contention is usually due to excessive hard passes caused by lack of cursor sharing. Implementing bind variables, cursor sharing reduces hard passes and latch contention effectively. Increasing PGA or buffer cache size doesn't target cursor pin issues. Disabling SUL plan baselines harms plan stability without solving latch weights. Question 19. In the modern context of Oracle database tuning, which tool provides the most comprehensive automated analysis combining workload statistics and diagnostic data to recommend improvements? A. Automatic Database Diagnostic Monitor (ADAM). B. SQL Access Advisor. C. Enterprise Manager Alerts. D. SUL Trace and tkprof utilities. Answer. Correct answer. A. Explanation. ADAM analyzes our snapshots and diagnostic data to automatically identify performance bottlenecks and recommend actions, making it the most comprehensive automated tool. SUL Access Advisor focuses on indexing recommendations. Enterprise Manager Alerts provide notifications but limited analysis. SQL Trace Prof offer raw trace data needing manual analysis. Question 20. Considering the evidence, which of the following best describes the role of the Oracle time model in performance tuning? A. It measures database time by categorizing EPU and wait time across sessions to identify bottlenecks. B. It analyzes SUL execution plans to find inefficient operations. C. It manages memory allocation between shared pool and buffer cache dynamically. D. It monitors disk I/O performance metrics only. Answer. Correct answer. B. Explanation. The Oracle time model focuses on measuring EP time by capturing CPU and wait times to pinpoint bottlenecks, not just SUL plan analysis. SUL execution plans analysis is separate from the time model. Memory management is handled by SMAM, and disk I/O is part of weights but not the sole focus. Thus, its core diagnostic framework for bottleneck identification, not limited to disk I/O or memory. Question 21. Within the framework of instance tuning, David finds his database suffering from excessive buffer cache contention. What is the most effective initial action to reduce this contention? A. Increase the buffer cache size to accommodate more blocks. B. 2 SUL statements to reduce physical reads. C. Enable automatic shared memory management ASM for dynamic resizing. D. Investigate and reduce hot block contention using partitioning or free lists. Answer. Correct answer, D. Explanation. Buffer cache contention often arises from hot blocks accessed concurrently. The best remedy is to reduce this contention by techniques such as partitioning or increasing free lists free blocks to distribute load. Simply increasing buffer cache size may not reduce contention if hot blocks persist. ASM helps memory allocation but not directly contention. Tuning SUL reduces EO but doesn't solve contention hotspots. Question 22. During a performance review, Sarah observes that her SUL statements exhibit inconsistent execution plans after optimizer statistics are refreshed. What is the recommended Oracle feature to stabilize SUL execution plans? A. Use SUL plan baselines to capture and enforce stable plans. B. Disable statistics gathering to maintain old plans. C. Force rule-based optimization. D. Apply optimizer hint aggressively in every query. Answer. Correct answer, B. Explanation. While disabling statistics might maintain old plans, it leads to stale statistics and poor performance long term. SUL plan baselines are the recommended way to stabilize plans without sacrificing optimizer effectiveness. Rule-based optimization is deprecated and less effective. Aggressive hints reduce maintainability and flexibility. Question 23. When analyzing an I report, Michael notices a high percentage of a DB file sequential read waits. What does this typically indicate and how should you respond? A. High single block read IO. Investigate inefficient index usage or contention. B. Large table scans causing excessive IO. Add more buffer cache. C. Buffer cache size is too large. Reduce it to improve performance. D. CPU is overloaded. Add more CPUS to reduce wait events. Answer. Correct answer, C. Explanation. DB file sequential read usually indicates single block IO, often associated with index reads or waits on disk reads. High weights suggest inefficient index use or contention, not large table scans. Increasing buffer cache generally reduces weights, but if too large, it can cause overhead. EPU overload does not directly cause these weights. Question 24. From a historical standpoint, Thomas is using the SUL Performance Analyzer SPA before deploying a patch. What is the primary benefit of using SPA in this context? A. To identify SUL statements that may regress in performance due to the patch. B. To generate new optimizer statistics automatically. C. To disable SUL plan baselines temporarily during patch deployment. D. To gather hour snapshots for post-patch comparison. Answer. Correct answer, D. Explanation. SPA is primarily used to test the impact of system changes by capturing SUL performance before and after changes, enabling detailed analysis of regressions, generating statistics, or disabling baselines are unrelated to SPA's core function. Our snapshots provide broader workload data, but SPA is specialized for SUL performance impact. Question 25. Considering the evidence, what is the most accurate description of the role of automatic workload repository IO snapshots in performance tuning? A. They capture periodic performance data to establish baselines and facilitate historical comparison. B. They provide real-time session activity data with high granularity. C. They control memory allocation between SGA components dynamically. D. They enforce SUL plan baselines for execution stability. Answer. Correct answer, A. Explanation. Our snapshots capture periodic performance metrics, allowing analysis over time and comparisons against baselines. Real-time data is better obtained via ASH. Memory allocation is managed by ASM. SQL plan baselines are unrelated to our snapshots. Question 26. During the process of diagnosing performance, Preya notices that her database sessions often wait on library cache pin latches. What does this indicate and how can it be resolved? A. Excessive hard parsing or contention on SQL statements, resolved by using bind variables and cursor sharing. B. Insufficient buffer cache size, increase buffer cache to reduce weights. C. High disk IO weights. Optimize storage configuration. D. Memory fragmentation. Enable automatic memory management tab. Answer. Correct answer, B. Explanation. Library cache pin latch waits usually indicate contention due to hard parsing or SUL statement concurrency issues. Using bind variables and cursor sharing reduces hard parsing. Buffer cache size relates to data block caching, not parsing latches. Disk I/O and memory fragmentation are unrelated to this latch wait. Question 27. In an effort to reduce SUL execution variability, which of the following best practices should Robert follow regarding optimizer statistics? A. Regularly gather and validate optimizer statistics using automated jobs. B. Avoid gathering optimizer statistics to maintain consistent plans. C. Always force rule-based optimization. D. Manually apply optimizer hints to control execution plans. Answer. Correct answer. C. Explanation. Avoiding statistics gathering causes stale stats and poor performance. Regular gathering is best practice for optimal plans. Rule-based optimization is outdated and generally not recommended. Manual hints reduce flexibility and increase maintenance overhead. Question 20. While examining system performance, Lucy identifies excessive weights related to disk I/O on temporary table space. What is the most effective tuning action she should take? A. Increase PGA aggregate target to allow more in-memory sorting and reduce temp space usage. B. Increase shared pool size to reduce parsing overhead. C. Disable IS snapshots to reduce overhead. D. Add more CPUS to speed up processing. Answer. Correct answer. D. Explanation. Increasing PGA memory reduces disk-based sorts and temp space usage effectively. Increasing shared pool size or CPU count does not directly reduce temp space weights. Disabling I removes diagnostic ability. Therefore, increasing PGA is the best first action. Question 29. The primary reason for using SULXS Advisor during tuning is to A. Recommend indexes, materialized views, or partitioning strategies to improve query performance. B. Stabilize SUL execution plans across optimizer statistics changes. C. Analyze wait events and session activity in real time. D. Capture and replay production workloads for testing. Answer. Correct answer. A. Explanation. SULXS Advisor focuses on improving physical access structures like indexes and materialized views. Plan stability is managed by SUL Plan Management. Wait event analysis is the domain of Ashevem. Workload capture and replay are handled by database replay utilities. Question 30. When examining performance problems related to latch and mutex contention, what is the recommended diagnostic approach? A. Use dynamic performance views (VViews) to identify specific latch mutex weights and their sources. B. Immediately increase buffer cache size to alleviate contention. C. Disable automatic workload repository to reduce overhead. D. Apply optimizer hints to reduce parsing time. Answer. Correct answer. A. Explanation. VViews provide detailed diagnostics on latch and mutex weights, including wait event names and session info, which helps pinpoint contention sources. Increasing buffer cache doesn't resolve latch or mutex contention. Disabling I removes critical diagnostic data. Optimizer hints may help parsing but are indirect here.